In this video, we are going to see how to deal with designs that we couldn't keep the factors at the design levels. Let's look into the following situation. A chemical engineer is investigating the yield of a process. Three variables are of interest: temperature, pressure, and catalyst concentration. The engineer decides to run the single replicate 2 in the power of 3 design and add 4 center points. The table shows the factors and their low and high levels. The first step is to build the design. The table on the left shows the set of treatments for a 2 in the power of 3 design. But the design also has 4 center points, so let's add them. The center points are coded with the number 0. The next step is to attribute the levels of the natural variables. For the regular 2 in the power of 3 design, the low level of the natural variable corresponds to the coded level -1, and the high level of the natural variable corresponds to the coded level +1. The center point is estimated as the average between the high and low levels of the natural variables. It is 140 for the temperature, 60 for pressure, and 22.5 for the catalyst concentration. Now we have the table with all treatment combinations and are ready to run the whole experiment. However, there is a problem. When running the tests, it was not possible to keep some factors at the design levels. Sometimes it is difficult to reach and hold the precise factors levels required in the design. Usually, small differences are not important, but large ones can hinder the analysis. In these cases, the regression model approach can be successfully used to analyze the results of experiments with fluctuant factor levels. The first step now is to correct the levels of the coded variables to match with the natural ones. We need to use the relationship between them. The coded variable xy equal to the natural variable vi minus the center point divided by half the natural variable's range. For temperature, for instance, we have xt equal to t minus 140 divided by 20. That is the half the difference between the high level, 160, and the low level, 120. Using this relationship, we can calculate the new levels of xt. As you are finishing this video, you have a to-do list before watching the next one. First, determine by yourself the relationships between xp and np, and xc and c. Download the data file in accurate.csv and fill in the missing coded variable values. You can use Microsoft Excel, macOS Numbers, Google Sheets, etc. Save it as a CSV file. Download the RCode file in accurate.r and open RStudio to analyze the data. Then you can start watching the next video. See you in a minute.